Tayo po ay magsitayo. Bilang pagpupugay, ilagay ang kanang kamay sa ating dibdib at awitin ang pambansang awit ng Pilipinas.
Madayaw, maayong buntag sa atuang tanan. Magandang umaga po sa ating lahat. Good morning, guests, friends, students, staff, researchers, faculty, and officials of UP Mindanao. You are in the first lecture for 2023 of the Department of Biological Sciences and Environmental Studies, or DBSES, of the College of Science and Mathematics, University of the Philippines, Mindanao. Today's webinar is part of the celebration of our College of Science and Mathematics Week of the 28th founding anniversary of UP Mindanao. Our department celebrates this week with the theme, Kinaiyahan para sa tanan, or Nature for All, para tayo ay sana all. All right, so good morning once again, and I am your host, Assistant Professor Cyro Susie Silvosa Miliado, broadcasting from the city with a wonderful smell of durian, pumelos, waling-waling, and the Philippine Eagles, Davao City. We would like to know also where you are from, so please join our chat box and tell us where you are, what is your preferred name, and where you are connected with. So while waiting, later on, please also put your questions in our Q&A chat box. Now, this morning, since the guest speaker is my mentor, sorry po talaga Sir Dong, but I have the pleasure to formally introduce you this morning. All right, now let's begin. Our speaker this morning has a BS in Agriculture, major in Animal Science from the University of the Philippines, Los Baños. So if you were his student, you would know he has a quite strong affection for cats. However, his love for animals seems to have extended to plants, as he took an MS in Horticulture, major in plant breeding, Is that correct? Sorry. Yes, plant physiology from University of the Philippines, Las Bañas. So after 5 years, he finished a PhD in plant breeding and international agriculture from Cornell University, USA. It was in 1997 when Dr. Rasco, or Sir Dong as we fondly call him, officially moved to UP Mindanao in the College of Science and Mathematics, where he served as Associate Dean. And later on, he continued serving officially as Dean for the same college. So he served for 2 terms until 2004, and he also served as editor-in-chief for UP Mindanao's journal, Banwa. He remains an active reviewer and the editor until present. Sir Dong taught various courses in UP Min, but he is most remembered for his very challenging STS classes, a course which he developed. In research, Sir Dong had pioneering outstanding contributions in agriculture, especially in plant breeding of tropical vegetables, with a long list of conference awards, journal publications, book chapters, and books. In UP Mindanao, he also established a research on agriculture, such as micropropagation, crop production, and alternative crop research, like NIPA, for food and fuel. After serving UP Mindanao in 2011, he served the Philippine Rice Research Institute of the Philippines as executive director until 2015. At present, he serves as interim president and chair of the Agricultural Sciences Division of the National Academy of Science and Technology of the Philippines. A virtual round of applause, please, to UP Mindanao's Professor Emeritus, Professor Eufemio T. Rasco Jr. All right, and since I believe he's having technical difficulties this morning, so we will listen to his lecture and then we will call him during the open forum. So, Sir Dong, the virtual floor is now yours.
Good morning. Let me thank everyone who tuned in to participate in this webinar. If you're busy and would like to leave immediately, the answer to the question I'm asking in the title is, we need a good balance of both silos and intersections. To be more specific, I would like to revive interest in developing biosystems engineering as a new transdisciplinary academic field in UP Mindanao. This will tend to tilt the balance in favor of the intersection part of my question. If you find these statements incoherent, please stay on. In the broadest sense, the objective for this talk is to guide us into looking forward instead of reminiscing about the past. Specifically, I will address the following general questions. First, for students, what courses, books, and other learning materials should we explore to be prepared for the modern world? For teachers, what teaching objectives, methods, and academic fields can we develop to produce graduates with relevant training? Let this talk not be a lecture but a conversation. Yung bang parang kwentuhan lang, tulad nung ginagawa sa Barberia nung araw kung inabot niyo pa yan. Consider this as an exercise in critical thinking. You need to wade through a lot of nonsense to find some sense. I guess this style of sharing is a privilege that seniors like me enjoy. If I make sense, you will say, of course, he makes sense because he's old and has accumulated a lot of wisdom. If I don't make sense, you will say, of course, he talks nonsense because he's old and maybe suffering from some kind of dementia. Seniority is both a license and an excuse seniors do not lose in barbershop talks. Whatever is your conclusion, I promise not to bore you with tables and graphs. I will use only a few slides, but I hope to draw your attention, if not active interest, in the most basic question confronting students and knowledge institutions today. Most of us grew up thinking that to be an expert, one has to know more of less and less. The problem with experts is this: if the only tool you have is a hammer, everything looks like a nail. I've witnessed this difficulty in the matter of diagnosing abnormalities in plants in the field. A geneticist looks at this as a mutation, a virologist, a virus infection, a physiologist, nutrient deficiency, and a nematologist, a nematode problem. Of course, it's also possible that all the experts are correct or all the experts are wrong because it is a problem that is not covered by the present domain of knowledge. Subject matter experts may be able to trace the cause and solve a problem without necessarily understanding the entirety of the problem and the consequences of its solution, causing second generation problems. The examples are drugs with harmful side effects, fertilizers that destroy the soil, automobiles that cause greenhouse gas emissions. On the opposite pole, we can imagine one who is a non expert, one who knows everything, but an expert at nothing. The problem with a non expert is that he may understand the problem, but cannot solve it because he does not have the mastery of the tools needed. They spend hours and days, sometimes endless debates and analysis of a problem, but offering no acceptable solution. Paralysis by analysis is the best way to describe this. But what if you are an expert with the capacity to understand problems like a non expert? Is this possible? Can we or should we not train people to be this kind of expert in UP Mindanao? While you are thinking about this question, let me make a confession. I started out as an animal nutritionist, turned to crop science, specialized in plant breeding, but always had an eye for developmental and socio-economic issues. In between, I got interested in history, philosophy, religion, agronomy, environment, and human health, among others. By the way, if I'm to teach STS in UP Mindanao again, these are the books I will likely assign to my students. Indeed, what sustained my interest in exploring knowledge is my assignment to teach STS at UP Mindanao for 12 out of the 14 years that I served this university. I can truly say that UP Mindanao and teaching STS transformed me, more perhaps than it did my students. I guess after all of this, you can call me a jack of all trades, master of none in a derogatory sense, or simply a curious explorer of all knowledge, an academic wanderer who has the luxury of time as a retiree. What I can assure you is that learning is indeed a continuing process. I learn something new every day. Yesterday, I fixed an electric fan, spending only 30 pesos for a spare part. It explains why I had to cram for this talk. It was the fourth electric fan that I fixed using the same low-cost spare part. It made me happy. A week ago, I fixed a state-of-the-art washing machine using a paper clip. And immediately after my retirement from UP Mindanao in 2015, I fixed an automatic garage door in my daughter's house in Florida using only tissue paper. I also fixed my daughter's iPad with a few plastic tools. Fixing junk is my personal solution to the problem of waste management. Email me if you want to know the tricks. But to give you a hint, number one, all of these modern gadgets, except for the iPad, share the same basic part, an electric motor. If you know how to repair one of these, you will know how to repair all of them. Second, you need to know how to navigate through YouTube for the technique and Amazon, Shopee, and Lazada for the parts. For educators and students, the lesson from my life experience can be summed up in one word: curiosity. And beyond that, the ability to establish connections. Let us cultivate these traits in every stage of life, and knowledge, discovery, and fun, maybe even profit, will naturally follow. I'm just starting to share with you my discoveries and learning in this amazing journey. The excitement that I felt discovering how things work and the principles behind them, and the connections among academic disciplines, the pleasure in seeing that I'm not alone as an academic wanderer, and the satisfaction that academic programs are taking notice of the importance of intersections among fields of knowledge. Towards the end, I will describe new academic programs addressing important knowledge intersections that are not adequately covered by today's universities and possible research agenda for each. I'm not questioning the importance of existing academic disciplines or silos of knowledge. I used to belong to one focused on plant breeding. They provide a depth, the trees in the forest of knowledge. I argue that the nexus areas composing the forest with its wildlife, microbes, supporting and providing functionality to the trees are equally useful. Indeed, the intersections give meaning and purpose to the silos of knowledge. Imagine that the forest of knowledge consists of intersecting circles of different fields of specialization. In the broadest sense, we can look at two main circles: traditional and modern knowledge. Traditional knowledge is holistic and integrative, and we tend to explain things we do not understand as superstition. Throughout my search for knowledge, I have learned to give traditional knowledge the respect that it deserves, which explains that the circle for traditional knowledge is infinitely bigger than modern knowledge. Note that there is an intersection between the two circles. I see that as a growth point. Indeed, I'm currently involved in an international project exploring this overlap or intersection. One way of imagining modern technology is that it's not entirely separate from traditional knowledge. Rather, it is a way of exploring and explaining traditional knowledge into manageable pieces. In the broadest sense, modern technology consists of natural and social sciences. Natural sciences is further broken down into physics, chemistry, biology, geology, mathematics, and others. There are integrative ways of organizing knowledge into technological silos. Among these are agriculture, medicine, and engineering. There are smaller silos. For biology, we have microbiology, systematics, genetics, etc. There are natural, intuitive intersections among these silos. For example, agriculture draws knowledge from biology, physics, chemistry, mathematics, and computer science. But it also draws on sociology and psychology. On the other hand, agriculture intersects with the knowledge silos of environment, nutrition, and culture, among others. Each of these silos, from the smallest to biggest, gets bigger and bigger, drawing from the growth of knowledge within it. Thus, there is a tendency to break them down into smaller and more manageable silos. This explains the conventional wisdom that expertise is knowing more and more of less and less. There is a popular joke among physicians that the field of medicine is so specialized that one can specialize on the left ear and another on the right ear. Amidst this salami cuts of knowledge, there are two approaches to making academic sense. On one hand, and discovering a purpose on the other. The organizing principles can be at the most basic level, that it is possible to use it to connect broad silos of knowledge. For example, DNA and evolution, both of which are acknowledged to be biological concepts, but they now apply to a broader range of academic disciplines, including those in the social sciences. They apply to individuals and societies, natural and applied sciences. It is fairly easy to establish connections within the domain of natural or within the domain of social sciences, if the purpose is to make academic sense. Indeed, the growth of knowledge and technology have been guided by these internal connections. What has been challenging is to establish connections between natural and social sciences. In many universities, experts belong to these fields or belonging to these fields tend to snub each other. I pray this is not true in UP Mindanao. This difficulty explains why environmental science, which depends on understanding the connection between natural and social sciences, is fairly late in coming. Compared to physics, chemistry, and mathematics, environmental science is an infant. You must have heard today's buzzwords that explain what I've been trying to describe all along. In increasing sophistication and practical value to society, we can classify ways of exploring intersections of silos of knowledge as multidisciplinarity, which draws on knowledge from different disciplines but stays within their boundaries. Second, interdisciplinarity, which analyzes, synthesizes, and harmonizes links between disciplines into a coordinated and coherent whole. And lastly, transdisciplinarity, which integrates the natural, social, and health sciences in a humanities context and transcends their traditional boundaries. Think of examples in your own fields as we go through this, but let me focus on the transdisciplinary approach. This is the approach that gave us environmental science, relating human activity to such consequences as climate change, pollution, and resource depletion. It relates natural sciences to behavioral and social sciences. This is the approach that we may use to create new fields of studies if we like to go beyond academic merit and move on to create value for society. To be able to explore connections, one needs a starting point, a handle, or an anchor. This is the role for expertise in a narrow field, the one we are familiar with. Let me illustrate the subject of uncovering or discovering connections by citing my recent experiences, lectures, and advocacies. My starting point is the discipline of plant breeding. This is my handle. I've been schooled in the Darwinian idea that plants live in a hostile environment, and the plant breeders' role is to provide the plants with the needed weapons to survive. Until I realized from a deeper study of biology and human societies that the dominant organizing principle of nature is not competition, but cooperation. Thus, I started campaigning for a change in breeding direction from competition-oriented to cooperation-oriented. Looking at plant breeding from this angle, I learned that the balance of soil microbes is a key to plant survival among other factors in the environment. Plant breeders must put more emphasis on breeding for what I call cooperation traits. Give plants a trait that will make it attractive for microbes to cooperate with them. The best example is symbiotic nitrogen fixation. If all plants can have cooperation traits like that in legumes, which endow them with the ability to harbor nitrogen-fixing bacteria, it may not be necessary to apply chemical nitrogen fertilizers in agriculture. Later, I realized that the same principle of cooperation exists between the microbiota of the gut and health of humans and other animals. Of course, you do not breed humans like you do plants. So breeding is not a solution for encouraging this kind of cooperation. Humans like surprises in their relationships. The approach should be different. Give the human gut microbiota the food that it needs so that it can contribute better to human health. It turns out that the food that gut microbes need is simple and very cheap. It is fiber. Give the microbiota fibers, and its population structure will change to one that endows better health for humans. Give it a lot of sugars, the food we take a lot of on a daily basis today, and the result is human disease. Here we see a beautiful intersection among agriculture, human nutrition, and human health. But the most astounding discovery so far is that there are similarities in microbial population structure in a healthy soil and a healthy human being. Nature is indeed wonderful. There must be truth to the religious teaching that humans originated from dust. So where do all of these discoveries lead us? Based on these insights, today I'm involved in a big cooperation project among us, Circa and Picard, the country's biggest agricultural-oriented knowledge institutions, for the purpose of campaigning for a change in the Filipino diet. The objective may be behavioral change, but its impact is expected to be more than human nutrition and health. If Filipinos eat the kind of food that will make them healthy, they will at the same time support local farmers and the environment. Behavioral change can open the gate for transformation in our food system. The challenge for the academe is to advance the transdisciplinary field to sustain this initiative, develop the field of biosystems engineering. To develop the field of biosystems engineering in UP Mindanao, we can start with what is already in place, but improve on it. In the University of Michigan, the Biosystems Engineering program combines biology with engineering to ensure there is safe and plentiful food, clean water, renewable energy, and a healthy environment. Students learn how to design resourceful solutions to technical problems involving biological components, including bioenergy, ecosystems protection, food safety, and biosecurity and human health. They may also learn about systems to transform biological waste into energy solutions and processes to detect or eliminate human pathogens from food products. We can use our existing programs in biology, architecture, agricultural economics, social science, and food science as handles for building our own version of this biosystems program. Initially organized them into a research program such as food system studies catering to graduate students Then the undergraduate level programs such as BS Biosystems Engineering can follow. Let me end this short presentation with three take-home messages. First, old-fashioned curiosity is the basis of all learning. It should be cultivated and coupled with the ability to establish connections. Second, upak. Utak, puso, at kaluluwa is the essence of a transdisciplinary program connecting natural sciences with social and behavioral sciences. And lastly, food system studies building on existing programs in biology, food science, architecture, agricultural economics, and social science can develop the UP Mindanao brand of BS Biosystems Engineering program. Thank you very much for listening, and good morning, everyone.
Thank you very much, Sir Dong, for that very interesting lecture. We learned a lot of things, practical knowledge, the value of cooperation, the importance na upakan na natin ang behavioral sciences and social sciences with natural science. And I do hope that our participants have been motivated and it sparked interest, especially on looking at systems with his lecture. So I guess for this morning, we can have a quick health break. And do please send your questions in our question and answer box. So Sir Vaughn, please take it. All right. Thank you so much.
Science may set limits to knowledge, but should not set limits to imagination. Here in the University of the Philippines Mindanao, we identify problems, create solutions, and explore knowledge beyond our imagination. And with that, we welcome you to UP Mindanao's BS Biology program, home of future biologists, doctors, educators, researchers, and anything that's related in the field. Under the Department of Biological Sciences and Environmental Studies, the program envisions a center of excellence in the fields of biotechnology and biodiversity in Brunei Darussalam, Indonesia, Malaysia, Philippines, East ASEAN Growth Area. Its mission is to provide excellent biology-related programs in higher education, research, and public service. Its goals are to offer a learning experience that encompasses the theoretical and applied aspects of the biological sciences, and for students to have a solid preparation for any career in scientific research, medicine, the academe, and other related fields through strong foundation courses, intensive practical laboratory, instructive field experiences, and complementing elective courses. Meanwhile, the program curriculum offers a minimum of 152 number of units. Here's a list of required courses and qualified electives.
All right, so join us sa bio na. If you're not yet from the bio program, do join BS Biology. So thank you so much. Lahat po ba ay nakapag-stretching na? May water na po ba? Okay, I guess we are now set. To serve as our moderator this morning is a professor who has been with UP Mindanao since 2003 as faculty or administrator. Her PhD is on horticulture under post-harvest physiology and agronomy from the University of the Philippines, Los Baños. She was a Fulbright visiting researcher in the University of Hawaii at Manoa, a Fulbright visiting scholar in the University of California, Davis, USA, and a visiting professor to King Mongkut's University of Technology in Thailand. She's a full-time faculty of DBSES and currently serves as a member of the pool of experts of the Philippines Department of Agriculture Region 11 and Department of Science and Technology Region 11. She's a UP scientist and the department's post-harvest biology and technology expert. Ladies and gentlemen, a round of applause please for Professor Emma Ruth Boyogan. Ma'am Emma, take it away.
Good morning. Morning, everyone. We are really pleased to have Dr. Rasco with us this morning. He talked about silos and intersections. Where is expertise heading? He described the different disciplines of knowledge as silos. In agriculture, silos are structures for storing bulk materials or fermented feed for animals or livestock. And this fermented feed is known as silages. There is also such a term as being a silo. A silo mentality is a way of thinking that is rigid and somewhat simplistic. Also, there is an organizational silo where employees pursue their own department goals instead of the company goals. I think this is a very brilliant way of the state of describing the state of some academic disciplines that persist to stand on their own. So thank you so much, Dr. Rasco. We have several questions in the Q&A. Can't seem to open my video, but that's all right. I've tried it a few times, but that's okay. We'll have the first question from Ernesto Guillen, the fourth. He says, I would like to ask if it would be better to incorporate some aspects of biosystems engineering into present courses such as BS Biology, or would it be best to establish a new course in UP Mindanao for BS in Biosystems Engineering? Let us please hear from Dr. Rasco.
Thank you, Dr. Bayogan, and thank you for the question. Very good question indeed, because it addresses the question of possibilities. Every curricular offering here, whether it's BS Bio or BS Social Science, AB Social Science, all of them have flexibilities as to the subject matter content. And in a formal sense, this flexibility is manifested in the form of seminars. If you look at your courses, every degree program has a seminar component. And in this seminar component, the one in charge is free to select the topic for the seminar. So that's the immediate possibility for the ones in charge of the seminar, not only in biology, but maybe also in food science, in agricultural economics, and in architecture, to incorporate some ideas about biosystems engineering. Because as I mentioned in my talk, all of these disciplines will be needed in the development of the BS Biosystems Engineering course. Regarding the course itself, I tend to look at this as a evolutionary process, the process of developing the course. And that's why I suggested that we start with research and development work. And this can be encapsulated in what I refer to as food system studies. So these food system studies can be collaborative work among the different disciplines that I mentioned, transdisciplinary in a sense, as in the sense that they will cut across natural and social sciences. So I think this is the way to go. And it depends now on the leadership of the university and acceptance of the academic community to get this thing going. Thank you.
Thank you, Dr. Rasco. There is a second question for you. It comes from Jericho Alfred Buen. He asks, what role do language barriers and cultural differences play in maintaining knowledge silos? And how can we overcome these obstacles to promote cross-cultural learning and collaboration? Sir Rasco.
Well, another good question. Definitely, there's a connection between language and culture. There seems to be a connection. Usually, those who speak the common language share the same culture, but of course not necessarily because of intercultural influences. You may be a Bisaya or an Ilocano, but if you are exposed to other cultures, then you tend to behave differently and tend to assimilate the values of the host culture. Now, the important aspect of culture that is involved here is the culture of sharing, because to be able to develop a transdisciplinary program, the first requirement is the willingness. The first requirement is the willingness to share knowledge and the willingness to listen to ideas of the other disciplines. So it works both ways. You need to be open to ideas, going out and coming in. Without this, it will be difficult, if not impossible, to develop a program like this. So in cultures where this openness is embedded, it will be easier. And I see a kind of hope in our culture because we have this sharing tradition, not only among Visayans, but I think it's quite common across the different cultures of Philippines. This is what we refer to as bayanihan, meaning mutual help, which is usually depicted as, helping your neighbors transfer their house from one place to another. This is give and take. If it's the neighbor's turn, then you help him, and if it's your turn, your neighbors help you. We can build on this cultural trait to develop this transdisciplinary program on biosystems engineering. Back to you.
Thank you, Dr. Rasco. While we're at it, there is another question from George. Bye-bye. He says, given the limited resources that UP Mindanao has, would it be possible to establish biosystem engineering program in our CU now? Also, in what possible ways can we incorporate our program, which is BS Biology, in case we are interested in studying topics involving biosystems engineering?
Well, to some extent, this has been addressed in the first question.
Mhm.
But without repeating it, I just like to emphasize that we are not starting from zero. We have the building blocks. It's only a matter of putting them together and looking for intersections among these building blocks so that we can build a house. Well, to pursue that analogy, how do you build a house? You need an architect, you need an engineer, but you need materials. I think basically we have most of the materials, if not all. We have the biologists, we have the architects, we have the economists, sociologists. These are the building blocks of the BS Biosystems Engineering course, as I describe it. But then putting this together requires an architect, an academic architect who can design the house, which is the biosystems engineering course, and an engineer who can build it, and someone who will push the idea through the board of regents. So we need a team of different experts to put this together. But as I said, the positive aspect of this problem is that we have the materials. Back to you.
Yes, thank you, Dr. Rasco. That means there would be somebody who would push it forward, starting from one college, maybe the College of Science and Math, and the interactions with the two other colleges, essentially everyone in this CU, Okay, there is a third one here. This time it's from Ira Brian Cabuenas, who is also from UP Mindanao. He says, it was highlighted in the lecture the importance of the transdisciplinary approach. However, it's possible that there could be differences in the ideas among various disciplines, which is true. How should we deal with these differences?
Well, another good question. I'm happy that we are getting very good questions here.
Yeah.
That speaks of the quality of our audience, the students. Congratulations to the faculty and congratulations to the students for developing this kind of expertise, this kind of curiosity to ask the important questions. There is a tendency, and it's quite natural, for experts to work within their silos for the simple reason that they are most comfortable dealing with people who understand what they're doing. But if they deal with people outside the discipline, then there's always the problem of being misunderstood, or maybe even hostility from the other disciplines. It's natural, but I think with the proper encouragement, this has to start somewhere. There has to be a demand for this kind of transdisciplinary cooperation, and it can come from the market itself, meaning maybe the students will be a market, and of course society itself will have to express the demand that they'd like to see a systems approach to solving our problem. We have tried before solving problems piecemeal, and it has led us nowhere. We have not solved our problems, and I'm talking specifically of our problem with the food system. We have, in my analysis, a very dysfunctional food system in the sense that it's not doing its job of providing nutrition and health to our consumers, which is, I think, the most important function of a food system. But at the same time, it's destroying our environment and making our farmers poor. Why did this happen? Because we tried to solve the problem of food piecemeal. We look at it from the production side, and so we produce what we can produce, or what the dealers and the processors can process, without regard to what the consumers actually need. So yes, there is a problem with silos, but someone has to break it down, and breaking it down will have to there has to be a signal, there has to be an encouragement, and that will come from society itself. Knowing that there is a problem with silos, so society itself should say, stop doing it, stop remaining in your silos, and talk to each other and come up with solutions. Back to you.
Thank you, Dr. Rasco. Let me go back to the questions, and they're really coming, and thank you so much for your participation. Before I go to Marco's question, I'd like to mention the question of Dolens James Inigo, which is a bit similar to the previous one, but Dr. Rasco might have other ideas about it, as well as that of Leonard Kent Elman. Dolens James Inigo is from UP Mindanao. He's a student of UP Min. The question is, how can we transcend the differences among different fields or disciplines of knowledge to foster cooperation and collaboration? And also that of Leonard Kent Elman, who's also a student of UP Min. He says, how can we bridge the gap between different disciplines and promote more effective communication and collaboration. They're about the same. And so I'll go back to the question also of Marco Lorenzo Toledo, who asks, which aspects can natural sciences foster better appreciation for social sciences, especially since the latter is not as much prioritized in the academe as compared to STEM-based programs. Sir, so three questions, they're related to one another. To you, sir.
Okay, very difficult question. If that's easy, then we'll have a lot of transdisciplinary programs all over the place. No? But the fact that the transdisciplinary programs are so few, it speaks volume about the difficulty of establishing one. To promote interdisciplinary cooperation, there's nothing like having an ongoing program. You don't just think about it, just do it and find out where it leads us. You cannot really have a good appreciation of a problem until you have actually dive into it and started doing transdisciplinary work. So I guess we should stop this talk about wanting to have transdisciplinary cooperation and start actually doing it by establishing a transdisciplinary program. I mentioned that a good place to start is transdisciplinary program in food systems, maybe starting with some research activities. And the challenge to this program is to solve the dysfunctionalities in our existing food system. I mentioned the dysfunctionalities. The consumers are unhealthy and they are not nourished very well. Environment is dying and the farmers are poor. You may look at it as separate problems, but actually they are part of the same problem, and we call it a systemic problem. To be able to solve this, then we need a systemic solution. The solution that the partnership of the National Academy of Science and Technology, CIRCA, and PICARD that I described is about solving it initially by working on the consumer, meaning that in our analysis, the consumer behavior is key. If the consumer persists on wanting to eat all this junk food, then they will continue to be sick. You see, if you've been reading the news, the main causes of mortality and morbidity in the Philippines now can be attributed to lifestyle. And part of this lifestyle is the kind of food that we eat. The last time I looked, about 5 out of the 6 major causes of deaths in this country can be attributed to what we eat. So we really need to change the diet for the sake of human health and nutrition. But at the same time, if we made the right choices, then it will also solve the problem of poverty in the farms and also the environment. By the way, I'm pleased to note that the advocacy for a change in diet that the 3 research-oriented agencies are now pursuing has the participation of UP Mindanao. There is at least, I think, 1 team from UP Mindanao that is participating in the app development contest that is ongoing right now. The contest challenges our society to come up with an app that that consumers can use in making the right food choices, so that we can address the dysfunctionalities in our food system. So there are many ways of approaching this, but there's nothing like taking action instead of just talking about the problem. Back to you.
Thank you once again. So may bagong app that the organizations would like to be developed. I saw two questions here, sir, and they're somewhat similar to each other. This is from Nicole Phoebe Valenzuela, a third year BS Bio student. She says, I'd like to ask, what role do personal biases and preconceptions play in maintaining or breaking down knowledge silos, and how can individuals work to become more open to diverse or different perspectives and ideas? And the question of Angela Ginon, what role do personal biases and preconceptions play in maintaining or breaking down this knowledge silos, and how can individuals work to become more open to diverse perspectives? So halos magkapareho po, sir.
Yeah, personal bias, of course, is a very important ingredient here, and it's something that you can train against. The kind of environment may promote or discourage these biases or this lack of openness. I think the culture in UP Mindanao that we have nurtured over the years has been the culture of openness. And so I'm quite optimistic that this will not be a major concern. I'm not saying that this will not be a problem, because we're dealing with individuals here, and there are individual differences. Some of them are more open, others are less open. But if the general atmosphere is promoting openness, then it will be easy for those who are prone to openness to express their openness in this kind of situation. So the quick answer is, let's create the environment for openness, for being willing to share our ideas and being open to accepting other ideas.
Okay, thank you again, Dr. Rasco. There is one question here as a student from an anonymous attendee. I'd like to ask how we can contribute this time in developing collaborative knowledge sharing cultures that will help our community thrive, considering the different fields of interest and expertise of each student. So as a student, sir, how can they contribute?
Okay, if I can take a few seconds, I just saw a warning that my battery is running low and I couldn't figure out the plugs. Okay, just
Please do. Yes, sir.
All right, so in the meantime, I think we still have a few more minutes, but I think, Ma'am Emma, we have to summarize the questions now. But do just keep them coming, because if there are questions that you really want to be answered, we can send them to Sir Dong and we can send it to his email. And he will try his best to answer the questions in his spare time. So thank you po. So I'd like to acknowledge the presence of our alumna. We have Dr. Rose Cachempo as our participant. Hi, Doc Marnie. Welcome back to the Philippines now. She's done with her postdoc. Yay! We have also participants from UP Los Baños and Open University and Leyte Normal University, San Pedro College, and UP Mindanao. All right, Sir Dong is back.
Oh, okay. Now, I'm not sure if I managed to solve it. What was the question again? I'm sorry, I got distracted.
Okay, sir. As a student, an attendee would like to ask how he or she can contribute in developing collaborative knowledge sharing cultures to help our community thrive, considering that different students have different fields of interest.
Oh, okay. I think the first thing to do is try to expose yourself to what the other disciplines are doing. Because if you know what the other disciplines are doing, then you can have ideas of how you can connect to them. And also encourage the other disciplines uh, to learn what you're doing. So it goes both ways. Learning what the others are doing and
Oh,
Uh-oh.
Dr. Rasco got disconnected, I think.
All right. I guess we just have to wait for a few more minutes until he
Yeah,
reconnects. I think he
but
did not figure out po yung kanyang connection.
right. But there are really a good number of questions. 29 now, plus there's one here in the webinar chat box also.
Thank
We
you
can
very much.
always, yeah, we can always forward these questions. I'll ask Sir Von to kindly save them for Dr. Rasco.
Yes po, ma'am.
Our ITO, yes, because there are 29 now, and I think I managed to take a look at only about half of them, but many of them are quite related with each other. About, oh, my connection is also unstable. About coming together like one system because we all live in one community to be able to address problems. And one way is coming up with an academic program on biosystems engineering. So takes a look at the sciences, the social aspects, and what the effects of all the activities and solutions on not just the human beings, but also on the other organisms and the environment in general. I think for a very, very long time, we have seen that doing it with your own discipline does not really work. You just tend to, have terms that is understood just by your discipline. So Dr. Rasco is not back.
He will try. He said he was really cut off, so he will try to be back. But I think we still have 4 minutes left for the question and answer. So maybe we can synthesize some of the questions. In the meantime, I think, Sir Juan, we can plug our lecture for next week if you have a copy. So we have face-to-face lectures in Lemito, but we will post the details of this one in our DBSES page. So please do stay tuned to our DBSES Facebook page. And we also have updates there. And you can also watch this video again. So we have Drug Discovery for Protozoan Diseases by Professor Tomoyoshi Nozaki from University of Tokyo, Japan. And this will be open in the university library. We also have Dr. Kumiko Nakada Tsukui from the National Institute of Infectious Disease, Tokyo, Japan. So we have shared some invitations, but this is a face-to-face event, so we really require you to signify for your attendance. We welcome researchers, faculty, and collaborators from other institutions, as they are also open to researches in collaboration with Japan. So napakagandang opportunity po ito. So if you're very much interested, do send us a message through our Facebook page or through our email. While we are waiting for Sir Dong, I guess you can also plug our site. Just please go to the DBSES Facebook page, because we have updates for our activities. The College of Science Mathematics week will be this week, but we're extending to the whole week of March. And the bio department has activities set whole year. On September, we will be having Knowledge Festival, so we will also participate there. And we look forward to seeing you as our participants and partners in our researches. All right, so sana makabalik si Sir Dong. Medyo mahirap po ang connection sa Laguna. Kagaya ng UP Mindanao, kaya close sa kanyang heart ang UP Mindanao kasi parating Laguna. Isa-surprise ko sana si Ma'am Emma kasi dang 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 secret kasi may pa-cake kami po ko sa kanya. So kung bakit ganun yon, amin na po yon. All right.
Actually, there really are so many interesting questions. Maybe while waiting for Dr. Rasco, there is a question about research involving different disciplines. There's a good number of research in UP Mindanao that involves researchers and students from different fields. Oh, Dr. Rasco is back. Welcome back, Dr. Rasco.
Sorry about that. Technical glitch
Yes.
again.
Yes, there are so many questions. I'm trying to synthesize them. There is a question here about the development of resilience, especially in conflict areas. Do you have some ideas or thoughts on that, sir?
That's a very good question, because when you talk about systems, you are talking about customizing them according to the realities of the environment where the system is embedded. So if you're talking about
Oopsie. I think it is really unstable on his end. So sana makabalik pa po. But anyway, do Sir Juan, and I think my colleagues here would like to ask for help to just take note of the questions, and we'll try
There
our
are many
best to
questions, yes.
yes po, to answer them through Sir Dong's email.
Yes.
So
Yeah.
I guess
So I think this is the only time that we have. Thank you so much to the more than at a point in time earlier about 80 plus participants, and more than 30 plus questions. I think for any webinar that we've mounted so far, this is one webinar that attracted a lot of questions. Thank you, participants, and we hope that you can join us again in our next webinar. Back to you, Ma'am Zay.
thank you very much po, Professor Bayogan, and thank you very much to all our participants. It was a very fruitful discussion, and sayang lang at medyo KJ yung ating technology and internet, pero dahil tayo ay magagaling at resilient, kaya natin ito. Okay. So I think it's also appropriate now to share our certificate of appreciation to our participants. So I'd like to request Sir Juan to please flash on screen the certificate of appreciation.